Good day, everyone. This is Tom Bishop. I'm the presenter for today's webinar on the EASA Accreditation Program, a review, and also a survey, some participant feedback that we obtained about the program in the past year. So moving right into it, as far as the questions, if you have a question, you can submit them using the chat feature and the instructions here that depending on the type of format you have with your browser and so on, you can either go in your lower left box for the entry of that information, or you can click the chat icon and open up a dialog box. The EASA Accreditation Program rolled out June 2014 at the EASA convention that year, which this June will be 4 years. It just seems amazing that we're approaching 4 years with the program now. And accreditations began shortly after that convention in August of 2014. And in this session, those who will benefit, I would say the most, would be not just accredited service centers, but any service center that's planning on becoming accredited. And for those that already are, some of this is obviously going to be refresher material, but it can be useful for planning for future audits and also in helping you better conform to the requirements of the accreditation program. Among the topics that we're going to address, the equipment required for the program and calibration of it, what is included, what's not needed, internal and external auditing, doing some planning there, what to expect, especially with external audits, and common nonconformities, the most common. We're going to compare over a few years' time from the program, from closer to the beginning of the program to more recently, and see, let's call it, how things have changed and how they've stayed the same. And also go over the current status of the program and then move on into the feedback from a survey of accredited service centers. It was a survey that was done like a statistical type survey. It wasn't 100% of those accredited. It was about 1/4 of those accredited that were surveyed. So the program, the heart of the program is its checklist. And all of this information, by the way, it's online on the EASA website on our accreditation page. And the primary reference document is our ANSI EASA AR100, the recommended practice for the repair of rotating electrical apparatus. And then the secondary reference is the good practice guide from the 2003 EASA AEMT rewind study. So the AR100 kind of puts together the heart and soul of it, and then for some more expanded details, you can expand on some of those items by going into the rewind study. And if you go through the checklist and you look at each item will identify the reference in AR100, and if there's an applicable reference in the rewind study, it'll also identify the exact location of that reference. So it points you right away to where you need to go to get the first-hand information. Equipment that's needed on the electrical side. Things like a milliohmmeter and ohmmeter. Some of these are relatively common in the service center. Ohmmeters, voltmeters, ammeters, and so on. Others are not as common, perhaps. A milliohmmeter, a bridge-type device, has 4 leads for measuring low resistance down into the millions, sometimes even into the micro-ohm range, and we need that especially for larger windings, for lead-to-lead resistance. A wattmeter, depending on what you're doing, a wattmeter might be built into a core loss tester as a machine, or if you're doing a loop test, you'd need a separate wattmeter. If you're doing space heater testing that's required in the program, to check the space heaters, you can check voltage or current, or you could check wattage. So if you're checking your space heaters with voltage and current, and you have a wattmeter built into your core loss tester, then you don't need another wattmeter for. In other words, that covers your wattmeter needs, and you may not need a separate wattmeter then. Okay. Other things, the megometer, high-pot tester, surge testers. The surge tester was something that was incorporated into the program when AR100 was revised in 2015. Prior to that, it was an optional. It wasn't required, and now it is. And in looking back, all of the accredited service centers from the first one on, in fact, did have surge testers, and they were part of the program. They were calibrated. So then you could have a core tester as a machine, or if you do loop test, you can do loop test. Again, using voltmeter, ammeter, wattmeter, all calibrated. Growler is a functional device. You just magnetize something using a growler, so it's not, the growler doesn't have to have a calibrated ammeter. The test panel has to be good to the rated voltage of the motor that you're doing an accredited repair on. So if you have a 4,000 volt motor and your test panel only goes to 2,400 volt, then you couldn't accredit that repair unless there is the ability to outsource. If you could outsource it to a service center that could test run it and had calibrated instrumentation for that 4,000 volt rating and could run it at the 4,000 volt. Mechanical and physical equipment, the left-hand columns, the mechanical, the right-hand side is the physical equipment. Inside and outside micrometers, many service centers use the outside micrometers with calibration on them to measure the values that are measured with the inside micrometers. In other words, the inside micrometer is simply used as a gauge. Other items, dial indicators, digital tachometer, some of these there's verification processes because they don't lend themselves to calibration, like a terminal crimper would not be calibratable, let's call it. Vibration measurement instruments, balancing machine, we see the footnote, outsourcing is permissible. Again, outsourcing on some things like that medium voltage test run, you might outsource that. It's not that a balancing machine is the only thing that can be outsourced, but it's a good example of one that's rather common, let's call it, for service centers to outsource. So if you outsource it to someone with a balancing machine, what you need to have for the program is the proof of calibration from that supplier, from that outsourced vendor, that their balancing machine, in fact, is calibrated, to the national standard for the country that you're in. If you have gauge blocks, these gauge blocks that we're speaking of here are the devices that are used. If you internally calibrate micrometers, you would calibrate those outside micrometers using gauge blocks, and those would go back to the manufacturer, to somebody that can certify them every 3 years. It's not an annual calibration. Just point of reference, calibration is required every year for anything that's in the program, and the exception being the gauge blocks, which are every 3 years. And the physical equipment, things like temperature meters, the burnout oven part temperature control, as part of the program, it's the part. So if you put a stator in the burnout oven, the part temperature has to be sensed. You can have temperature sensing for the burnout oven itself, but for the program, what we need is that you monitor the part because it's the part temperature that's critical. If the burnout oven goes to 800 degrees and the part only goes to 650, the limit for the program is 700 for the part, you're still okay. But if the part goes to 750 Fahrenheit, then it's above the 700 limit, and that's an issue. Other things, burnout oven, a water mist to know that there's control on over temperature conditions and so on. Winding machine verification, turns counting. If you have VPI, then the gauges, the vacuum and the pressure gauges need to be calibrated. And that's a key point, as simple as it is. One of the big things, not one of, but the biggest thing I have found and seen from audits is that calibration is the number one issue. And if someone has a VPI system, I'm not saying it's the number one issue with someone with a VPI system, but it's unusually high the number of times that someone with a VPI system has an audit and they find that their gauges aren't in calibration. In other words, the calibration date has passed. It's out of calibration by calibration date. So what is and what isn't required? Really what's required, it's whatever's on the calibration list, the equipment list, that's in the checklist. There's an Annex A, and you can see these website addresses here. You don't really need to write them down. Just go on the accreditation page. That's a drop-down, a push-button click on the EASA website, www.easa.com, and you can get into accreditation, the equipment, go into that annex, and whatever's on there in terms of equipment, that's what you need. And again, things like that watt meter, maybe you need it, maybe you don't. But you need a watt meter in some form, especially for core loss testing there. It's either built into the core tester, or you would need a separate meter if you're doing loop tests. And again, the complete checklist, there's a checklist and there's a checklist with explanations. What's the difference? The checklist is simply the checklist. There's 73 line item categories in that checklist. And then the checklist with explanations provides additional detail to explain what is it that checklist item is speaking about, and gives you some guidance on how you're going to do something to make sure you conform, that you follow what's required. Again, mentioned this already. Whatever's on the list, it needs to be calibrated. It needs to be functional. If you have a test panel and it's calibrated, if you can't turn it on, that's not really a help for you. So the point is that whatever you have, the equipment has to be calibrated and has to be in working order. Annual calibration, mentioned that. Record retention, you need to have your records on file for 3 years or until the next internal audit, and that's following the initial accreditation. If you go into the accreditation program and you purchase a brand new core tester, the calibration for the core tester that's brand new, you can't have a record going back 3 years. It's not been there that long. So that's what we're trying to do is make it realistic and say, no, after the initial accreditation, whatever's in there, it's like grandfathered in. From there on, you need to keep those records for at least 3 years, at least until the next external audit. And if you have an item that you're using for testing, maybe it's, example here, the DC test panel, or your DC voltmeter, DC ammeter, accredited repairs at this time, the scope of it, it's 3-phase squirrel cage induction motors. So a DC motor, you can't put an accredited repair label on it because it's not within the scope of the program. If you run test a DC motor as part of the program to make it clear, especially to an external auditor, that you don't use that panel for testing accredited repairs, you can mark the panel for reference only. Would encourage you to get it calibrated anyway, just as a good practice. If you've got known calibrated meters for your AC accredited repairs, wouldn't it be good to have it also for your DC, just to give your own firm that higher level of confidence that the values you're measuring are correct, that they're accurate. Examples of instruments that could be used but not calibrated were the inside micrometers, where they're used as a gauge. You take the inside measurement and then you measure it with the outside micrometer that's calibrated. So you use that as a way of getting the measurement. Okay, there was a question about a plus or minus tolerance on the 700-degree limit. The 700-degree Fahrenheit limit is it. In other words, 0 to 700. Over 700, it's beyond the limit for the program. So that would be something that would say there's an issue there because there could be core damage as a result of that. So it is a 700-degree limit. It's not, it's not 700 plus or minus 10. It is 700. Essentially, it's 0 to 700. So it's kind of like a minus 700 and plus nothing in a way. Of course, you wouldn't, practically speaking, be able to process it at really lower temperatures. But the point is that's a not to exceed number. Internal and external auditing. What's required? What's not required? In terms of what's done, there's internal audits. There's what we call beta audits. What a beta audit is an internal audit that you do in preparation, usually for your external audit. And that beta audit is where you try to take kind of a step back, a arm's length approach, so to speak, to look at how you're doing what you're doing and make sure that you're in conformance with the program. When it comes to something like a beta audit, a good way to do that, if possible, is maybe you have somebody who's a recent retiree, or maybe even not that recent, but someone who worked at the firm, they're now retired, but they know the system, they know how things operate, and have them come in so that they're not involved with the day-to-day, doing things, and have them do the audit. Or have somebody who's let's say, an office person who's familiar with the plant operations that can go through the plant, as opposed to if you have something like someone, like let's say a winding person, or a winder or a mechanic or a machinist or a foreman out there on the floor involved in the day-to-day doing the audit, it's hard to be as objective as you really want to be, especially because you want to try and kind of set your view on, if I were an external auditor, how would I look at this? So internal audits, setting them up, select an audit team. In most cases, that audit team, we use the word team, seems to imply, more than one person. Does not have to be. Typically, it's going to be one person that's going to go through. What I would suggest, if you're doing what we call a beta audit, preparation, probably a good idea to have two people so that, it helps to maintain the objectivity. But after that, internal auditing, do it one person. In most cases, that's fine. That's enough. You do have to audit at least annually for the program. So there's after you're audited externally at the first year point and the second year point, you have to turn in documented internal audits. And you audit the complete checklist. There's, like I say, I mentioned there's 73 line items. Every one of those line items has to be audited, and it has to, it has to come out. It's essentially pass-fail. If 1 out of 73 doesn't cut it, then the audit is not complete until that 1 out of 73 is in fact complete. Jumping kind of on a fast forward, in April, as of April 1st, we're making a slight change in the audit checklist. Right now, it has a couple of columns for what's called major listed as MA and minor listed as MI. We're simply eliminating those MA and MI designations to eliminate some possible confusion, to simplify and clarify the list. That reality is everyone that's been involved with the audit process and service centers that we've seen from the audits, every item is treated as a major item anyway. So rather than change the MIs, minors to MAs and have them all be MAs, we just got rid of the column, and that's going to go into effect April 1st. Nothing has to change in the way you do your work with the program. It's just basically like an editorial change on the checklist. So next thing, reporting findings. Whatever you find, if you're doing an internal audit and you make that report and it's going to go to the external auditor, you want to show them that there was follow-up on the findings and that those findings were resolved when you sent it on to the external auditor. And certainly for your own benefit, if with an internal audit, if you find something that's not right, you want to expeditiously go after it and make sure that it's resolved. And at that 1 year and 2 year interval, you're going to send that copy of the internal audit report and any follow-up to the external auditor, who would then accept it. If they accept it, or they'll get back to you, and then they send it on to EASA, and your accreditation is continued for the next year. Beta audits, not a program requirement, highly recommended. I honestly cannot, how would I say it? I can't emphasize how important it is to do these beta audits, and particular when you do these audits, whatever you find, treat it with objectivity, follow up on the findings, and particularly in the calibration areas, make sure that things are calibrated. If there's a finding where somebody is, let's say, not, maybe one of the checks is with the tachometer, is checking the speed on the no-load run test. If somebody's not following that, or if it's not on your documentation, modify your documentation and add that to your document so that it's a known that you're going to do that test. Evaluating the readiness when you've gone through and you've done an internal audit and you say, we went through every item on this checklist and we conform. Everything's in calibration. Everybody's on the same page. The winders are doing what we say the winders are doing. The mechanics are doing what we say the mechanics are doing. The machinists are doing, and so on. We're ready. And then you bring in your external auditor, and quite frankly, I don't think you'll be surprised, other than pleasantly surprised, that they're going to come in and say, okay, everything that you have is in conformance. If you've done your homework in advance and gone through this checklist, again, my view after reviewing, I review every external audit that's submitted to EASA, and what I conclude from it is that every one of the items that was amiss a finding, it could have been resolved. It could have been identified by the service center if they were, a little bit, let's call a little bit more attention. Just make sure. The auditors, the external auditors, they're good too. To be honest, fair. They're fair, they're honest, and they're thorough. So, you're not going to have something that's not calibrated and expect that the auditor is going to miss it or overlook it. EASA auditing firms. There are 4 firms that are approved to do audits of the program. 2 in the U.S. That's Advanced Energy in North Carolina, and there's Green Motors Program, which is in the West in Idaho. In Canada, Enertech Solutions in Ontario, and in the UK and England, it's SGS Pacifica. So we've got, and by the way, any one of these 4 firms will go anywhere in the world to do accreditation audits. The frequency, the external audits, is every 3 years. So right now, we started out in 2014. We now have over 24 service centers that have gone through the external audit for the second cycle. In other words, they had the initial audit, and now they've gone through the second, the second external audit. They're in the second cycle, and those who, once they start the program, again, it's after you go into the program at year 1, you have to submit an internal audit to the external auditor, and at year 2, you do the same thing. So all of this then is acknowledged in an audit records. He said we have an audit record for every service center. If you want to know who is accredited, you go on that accreditation page, and you can find the list of all the accredited service centers. External audits, what are we trying to do with an external audit? It's the objectivity, it's the independence to say that that somebody from the outside, not just outside your firm, but outside of EASA, has come in, has looked at your system, your equipment, how you're doing what you're doing, and they've proved that you are in conformance. In other words, what they're looking for, they're not looking for where you didn't do it. They're looking to find the evidence that says you are in compliance. You are doing what you say you're doing for the benefit, to fulfill the requirements of the program. Accreditation audits so far, 1 day has been what it's required for an external auditor to come in. When we first put this program together, let's call it on paper, we weren't sure how long it would take. Would it be a 1 day? Could it be a half day? Might it be 2 days? But so far, and we've gone through over 100 external, firms, service center accreditations, it's been done in a 1 day period of time. And the external reaccreditation, again, still a 1 day period of time. There's always the potential for it taking longer if there's, a lot of things that have to be followed up on, that the auditor either may take longer than a day or potentially the auditor might have to come back. So those are possibilities. But again, overall, not that it's set in stone, but it looks, pretty solid that 1 day is what's required for the accreditation. Preparation, housekeeping. Make it, think of it like you've got your potential or your number 1 customer coming into the plant, and you want to have that plant, looking, you want to put your best foot forward, have it look really good, and that's the housekeeping aspect. And not just for the auditors, but certainly, you want this on an everyday basis as well, especially for safety reasons. The needed documents, make sure everything's available. The auditor's going to be there for a day. If they ask for records and it's going to take you a half a day to find the records, you might be the first service center that goes into a second day audit. So you have everything ready. An action plan for the findings. That, you can't predict what the auditor's going to find, but you want to know, you want to not know, you want to have set in your mind that if the auditor finds something, here's our lead person for the accreditation program, and they're going to say, okay, I'm the lead person, and here's my go-to person that's going to help me, and we're going to get this resolved. If it's something where, an item has to go out for calibration, whoever handles sending the instruments out for calibration, that's who's going to be involved with working with resolving that issue, as expeditiously as possible. Common nonconformities, how to prevent them. again, I mentioned this, no external auditors needed to return to the service center. Again, we really don't want to see anyone be the first, and hopefully this will continue on, into eternity. The number of findings has been decreasing with time. That when the program first rolled out, service centers were just, let's call it, I guess, getting used to it, looking at, and they weren't sure it was, the program was in its infancy. And I think there must have been some, let's call it, cross-pollination, some sharing of information from service centers that were accredited and those that weren't yet, where they shared information and learned from each other. And those who, got into the program a little bit later realized that, okay, here are the things that are required. Also, some of the awareness of, information we put on the website about, what to make sure you have, and webinars like this, so that everyone's, up to speed on here's what's required. And again, it's as simple as it sounds. It's still detailed, 73 line items. Meet those, and you're conforming to the program. The audit findings that were found, that what was found, if there was a beta audit, a thorough beta audit that went through and corrected the issues, when the auditor came in, there would have been no surprises. All the 73 items would be met, and your accreditation would happen immediately. That basically the next day they'd be, or even sometimes the same day, they're sending in a report that says, this, we've audited the service center, and here it is. We've got all the, everything's up to snuff. It's in conformance. We're ready to go. The findings. In 2015, I went through, again, statistical, not 100%. Although, actually, I take that back. In 2015, I think I went through every one of the audits at that point in time. 2017, there simply were too many audits to start, to keep doing that, so it became a statistical approach. But what was found was winding removal and core integrity, that, the removal of the windings. We can see those high percentage, 18%, even higher in 2017, 35%. Now, this is a little misleading. It's not that there were that many more. In 2017, the number of findings were less overall than we found in 2015. So it's a bigger piece of a smaller pie. So that's a positive thing. But the point is that winding removal, core integrity, if you want to know the number one thing to be looking at in your program, go through those, the category for that, go through that and make sure that you really are in conformance there, because that's probably your a number one weakness type area. If you look down, scan down a little down to winding impregnation, went from 6% to 20%. So things to do with winding, pretty big on the list as far as potential for nonconformance. Other things, no load tests and so on. We'll look at some of these items in more detail. The winding removal, core integrity, 2015 to 2017. Most findings, common thread, 2015 and 17. Post versus pre-winding removal core test, lacking. That what it really came down to is a lot of service centers are used to doing the post burn-off process core test. But what the program also requires is to do that core test before the winding removal, so that we can compare the after to the before to be able to prove that we haven't increased the losses, to a measurable or, significant amount. And auditors also observe things like stators with splayed teeth, which I think has been starting to diminish. Core tests are not calibrated. It's a calibration item that, again, a big factor, a relatively high percentage where core testers were not calibrated. So make sure you have a core tester, if you have it, that it's calibrated. In other words, that the calibrations, that you within the calibration period. If it was due for calibration last month and the auditor's coming this month, it's not going to play well, because they're going to have to say it's not in conformance. Also, there was a case in 2017 where somebody was using chemicals in an open flame. They hadn't yet purchased a burn-off oven. So one of the things, they purchased the oven. They also purchased a calibrated core tester. So they brought themselves into conformance by doing that. Impregnation of the windings, common thread, there's lack of the VPI. So it's not the standard day-to-day dip and bake that were the big issues. It was the VPI gauges that weren't calibrated. And if you're not doing VPI, If you're not doing accredited repairs on any of the windings that are VPI processed, you'd label the VPI gauges for reference only. But again, if you do that, then you can't accredit a repair that's been VPI processed. Also, 2017, a bake oven temperature meter calibration lacking. So that word calibration seems to be another common thread. No load testing. Not that it was a big issue, but the thing that stood out, the no load speed not being recorded. That you have the digital tachometer, but it wasn't, every job it wasn't recorded. That's probably an important thing there is have it as part of your repair record form to say, here's a line item entry that you have to fill out. If it's there and you know you've got to fill it out, it's going to happen. I might have jumped through one slide here. Oops, yeah. Okay. The recipe for success is, create an internal task group facilitating the program that, give it to somebody, a group, more than one person, so not just one person has to shoulder the load, and implement the program. Maybe you have somebody that's going to, help in the winding area, another one mechanics, another one machinist, another one with calibration, that type of thing. Spread the work around, but work together as a group. Make sure they're empowered to do what has to be done, and then go through with auditing, beta auditing, the checklist. Make sure that everything that's on that list is followed. Become familiar with especially with AR100. Your people on the floor, the mechanics, the winders, the machinists. Let them see just what it says there. Have copies of AR100 readily available. Also, as another reference for further reference to good practice guide. Where each of those line items cites a reference. Look up that reference, see what it says. Make sure all the equipment's available and calibrated. Again, if you bring an outside auditor, external auditor in, and your surge tester has been sent out for calibration, they can't check that. So you need to, then be able to provide proof that it was calibrated post-audit, and it's going to delay, things like your accreditation. Beta audits, again, following up on the findings and being as objective as possible. Not saying, to be hard on yourself. Be honest. That's the main thing. Be honest and say, look, does this cut it or does it not? If it looks like, if you're trying to, let's call it rationalize that it's okay, it's not okay. Findings from external audits, make sure whatever the external auditor finds, respond to it as quickly as possible because it's delaying your accreditation or your reaccreditation or your continuing accreditation if it's the 1 year or 2 year point. The timeline, and this is taken, you see that web address, EASA.com accreditation/process. This is on the website, so it's kind of small here on the screen, but if you look at it, we start preparation, download the checklist, go through it, review it, and so on. Plan for what you're going to do, send in your application, and so on. Then you move into, the EASA website lists the auditors. You make contact with them. Maybe you could select 1, 2, 3. You could take all 4 and have them all give you a proposal for what it's going to cost for them to come in and do your audit and become your auditor. And then you select the one that you feel most comfortable with, and you move forward. And they do their on-site audit. Let's say you get through that, and then you're into year 1. At the end of year 1, just before that, you're going to do your internal audit. You're going to submit it. The auditor, and again, see what we have with the auditors. The auditors, from what I've seen, all these audits, whether it's the the initial or the first year, second year, they're very good. Fast turnaround. It's not like you send something into the auditor and you have to wait weeks to get an answer. So, year 1, year 2 point. Now at the end of year 3, you're approaching it. You're going to prepare for your external audit. So you're going to probably want to do, again, it's not required by the program, but you'd want to do, and I would want to do an internal audit, pretty intense, beta audit style, mock external audit to get, to be prepared. And before you get into it, and not that we're so worried about money, but you do have to pay up front. That you have to pay for the EASA renewal fee before the auditor can come in. So make sure you get, don't put the cart before the horse. Get the fee submitted so that the auditor can then come in. You don't want to delay the ability of the auditor to come to your site. Impact of accreditation. This was a sample survey I mentioned. Was about 1/4 of the accredited service centers, and this was within the last year, 2017. And putting it together, looked at a wide breadth of geographic locations. In other words, we've got members not just in the U.S. but in North America, but also in other parts of the world, in Europe, Asia, and so on. So we made it as wide of breadth as possible, and we tried to go as wide, and we went, let's call it, as high and as deep in terms of, size of service centers, from larger ones to the smaller ones in the accreditation program. And it was not a lengthy survey. It was 3 questions. How's the accreditation program improved your business, internal operations? How the program improved relationships with customers? And how has the program provided any economic or other benefits? And, out of those, the feedback from that, just to pick the first question about the accreditation program improving internal business. Found that in a 2-year period, failure rate was 5% less for repair than it was for new products. So what it meant was, what the service center saw is that what the service center product that was being put out was, more reliable. And that's a big part of the program is not just efficiency maintenance, but reliability. And here's an indicator of reliability improvement. 5% less failure rate on repair versus new. Another service center, a large drop in warranty and quality issues almost immediately. 0 accredited repair issues over a 2-year period. Across the board, dropped from 3% to 0.4% warranty versus total number of repairs. So that's a huge drop. I mean, that's like 10 to 1 almost. Continuous improvement. Accreditations help follow consistent processes and procedures. And another side benefit that when you're following AR100 and you have your repair documents aligned with that, you're following the good practices. It's always a lot better. We say it all the time, but it's true. It's easier to do it right. It's better to do it right the first time, than have to do it a second time. And it certainly costs a lot less if what you put out doesn't have to come back and be reworked. How has the program improved relationships with customers? Here's one. It's a small shop, less than 10 people, and their customers are surprised that they, as a small service center, are involved in the program, but they are, and they're producing, again, good quality repairs by following the accreditation program. Accreditation, another one, service center, building trust. The program addresses not just the electrical but the mechanical components and resonates with many of our important customers. That customers look for, what are you doing for me? How do I know, that what you're doing is the right way? And this is where we're able to show it to the customer that we're following the good practices of AR100. Accreditation helped demonstrate evidence of hard work, high standards. Motors last longer, perform better. Reliability, and that's, again, a big thing is reliability, especially with customers. If they're involved in the maintenance end, efficiency is nice, but reliability is what they're interested in. Economic benefits or other benefits. Proven quality repair, longer warranty. They're providing this service center providing a longer warranty than a new motor. Repaired motor, good bones. In other words, done right, saving money, saving the environment, saving energy. First 6 months following accreditation, a service center was contacted by companies they'd never done work for, specifically stating they needed to use an accredited repair service center for their motor repairs. And there are some end users, some customers out there that do have a requirement that you have to be an accredited, EASA accredited service center. The process has been the single most important change in the history of our company. I mean, that's an astounding statement. In only 2 years, we couldn't have asked for a better return on investment. So that's some pretty strong words. Okay, where are we at today? The number of accredited service centers, 110. The benefits to those who've become accredited, fewer warranties. We've seen some mention of that. Customers having greater confidence in the reliability of the repaired motors, customers having greater trust and confidence overall in the service centers, and that service centers are being able to attract new customers because of being accredited. So, to summarize in conclusion, not summarize, let's call it a conclusion, some objective evidence here of maintaining the efficiency of the repaired motors. This is these were 7 different motors. Actually, it was, let's see, it was 7 different motors at 6 different service centers, and I can't off the top of my head remember which 2 were from the same service center, but that doesn't matter. We've got 7 motors from 10 to 250 horsepower, wound anywhere from 1 time to 12 times. And if we go over, don't worry about the full load efficiency before or after as far as what the numbers are. The one on the right-hand side, change in efficiency. It ranged from a plus 0.5% to a minus 0.4. That meant we went from an efficiency increase of about 0.5% to a decrease of about 0.4%. And if you're doing efficiency testing and so on, and trying to compare, especially if it was what they would call a round robin, going from one facility to another to be tested, the usual rule that I've heard is about any variation that's plus or minus 0.2%. It's really not telling you there's a difference. So there's a couple, the minus 0.4 and the plus 0.5, that might say there's something that's been done to the motor that either affected it negatively or affected it positively. But overall, it's really no change. And look at the overall efficiency change for the whole group of 7 motors over those times, multiple times of being rewound and processed, 0.04%. So really nothing, no change at all. So, okay, we're at the point that's it for what I have to to present, and I wanted to leave at least 15 minutes for some Q&A, and we're about 12:42, 12:43 now, so. Let's call it the floor is open to bombard me with questions. Okay. Now, to ask a question, you have to use the chat button. So it's not a voice Q&A. It's a send in a chat note, and I can answer the chat note. Okay. I saw some hands up indications. Now, if somebody's a 2-finger typist like me, it might take a moment for them to get the question to come through. There we go. Okay. Reliability is a major issue. Can you be more specific on how reliability is measured? Okay, I like to say that's a good question. Usually what I also tell people when I'm doing things like seminars is when I say something is a good question, it usually means that I have no idea what the answer is and I need some time to think about what I'm going to say. But in this case, reliability, how I would measure it is, you repair the motor and you send it out. How long does it take, like mean time before failure? When you send it out, how long does it last before it has to, come back to the service center for the next repair? Now, that to me is a very good, very objective measurement. The real challenge, though, is that when you repair a motor and you do a really good repair on it, if it's out at the customer site for years and years and sometimes for decades, you just don't get the feedback data to know that reliability, has been enhanced. But one measure of reliability that you could use is if you, again, with objectivity, look at your warranties. If you are producing a product, a repair, that's improved now from what it was a year ago, your warranty rate from what you ship out to a customer to what they return, your warranty rate will go down. And if you're also doing things where you have a way of monitoring your internal warranty, let's say the machinist bores an end bracket out or machines a shaft and the dimension is incorrect, you discover that internally and you repair it and then you correct it and send it out. When it goes to the customer, it's correct, so it doesn't affect your external reliability. But again, that's measurement. Your internal warranty and your external warranty rates are objective measures. Again, when I say objective, if you're reporting it, if somebody's covering, let's call it covering it up, it's not going to be good data. But that's one simple, straightforward, but very useful way is look at your warranty rate. Okay. Is there a date in mind for adding DC? No, there's not. We don't have a date yet. What we're still working on is we want to get the program up, the number of service centers in the program. We don't have a set number, but we'd like to see more service centers in the program and then look in the areas of things like DC motors and synchronous machines and so on. Some of the more common motors to add, and DC would certainly be a logical next step to go to looking at those for the repair program. Can a vertical hollow shaft motor be certified when the upper bearing can't be measured? If you're doing an accredited repair, you would need to measure that fit. So if you have something like the housing fit where it has a tube, there are some devices that can be used that can measure over the tube, or you might need to remove the tube to measure it. So you would need to have dimensions in order to meet the requirements of the program. Was the data in your last slide from the EASA AEMT rewind study? No, that data was something that was obtained during the course of doing the the survey of accredited service centers, where we asked them if any of them had their equipment, if they had anybody who had done some lab testing on motors that they had repaired. So that was those 7 motors. That was feedback from the service centers, but not from the AEMT study now. Is or was the accreditation program presented to the Department of Energy, and how does that play into the future of repair shops? No, the accreditation program, the Department of Energy, the people that are involved in the areas that get into, especially like the new motor efficiency, we've made them aware that we do have this program, but we haven't submitted it, let's call it, to them in any way for anything as far as for one thing, we're not, we don't want to offer them this as something that maybe they should consider for rulemaking. So, we don't want to tempt the bear. Okay. Any other questions? If you have a question, there's anonymity. I mean, I see who the name is, but you can trust that I don't have a good memory when it comes to people's names, so I'll forget who asked me the question and I'll give you the answer. So it's for the benefit of all, especially if there's somebody that's a service center considering accreditation. If you've got any questions, this is a good time to ask. There's no bad questions. There's no dumb questions. We get some things that seem so straightforward until you ask them and you say, well, wait a minute, there's more to this than meets the eye. Okay. Is chemical stripping allowed if core loss readings are taken? Yeah, I mean, if you do your winding removal, not just something like a chemical, and you're going to do your core testing, or there are some older windings, especially some old form coil windings, where you can remove the coils manually. You just, you manually drive out the top sticks and lift the coils out. So it's not that the oven is mandatory. It's if you're using the oven, it has to comply. But if you can get the winding out without using the oven, yes. We don't want to see somebody using an open flame, because the core test is going to find that, where that open flame was used and it came in contact with the laminations, we're going to find that there's going to be hot spots. Okay. Surge testing EAR % guideline. The accreditation program doesn't provide any specifics to this EAR, which is an error area ratio. For that, the best thing to do is get with your equipment manufacturer, because the different surge testers, I believe, have different values that they use, and there's no standards for those. That's something that the equipment manufacturers developed. And they have their own guidelines, but there's nothing like there's not an EASA standard, there's not an IEEE, Institute of Electronic Engineers, or International Electrotechnical Commission, IEC standard for that, so those aren't covered by that. Any other questions? I'll wait a few seconds here and see if somebody else has a question. If not, we'll move on to conclusion. Okay. Well, then the next webinar will be in a month, March 21st, on requirements to service hazardous location motors, and that'll be presented by Jim Bryan, EASA Technical Support Specialist, my colleague. And so thank you for all your questions. I hope you got something out of this presentation, something useful, whether you're accredited or not accredited, and certainly if you're not accredited, really would encourage you to keep going with your efforts, and certainly if you have any questions, give us a call in technical support if it's something about the accreditation program. I'd be happy to answer them. So I thank you very much, and I wish everyone a good day. Thank you.